Hi, in this video I'm going to be talking about how to solve a word problem, a geometry word problem in this case, but I'm going to be using the minimum maximum feature on our graphing calculator in order to solve it instead of doing it by hand. Okay, so here's the problem. I'm going to make a rectangular box out of a flat piece of cardboard. And the way that I'm going to do this is I'm going to cut right here on the side. You can kind of see the little cuts. I'm going to cut a flap on the sides and I'm going to fold it up and I'm going to make this box. Okay, it's a very pretty box. The question is, if this piece of cardboard is 16 by 20, when I fold it up, I want it to have the maximum volume possible. So the question is, do I make it like a smaller base that's and a taller box, or do I make it a very flat box that's not very tall, or what do I do here? How do I make the most volume? How do I get the most volume out of this box shape? And so that's what we're trying to do, okay? First things first, we're talking volume, right? And we're really talking the volume not of the flat piece of cardboard, but of this guy, right? And so whenever I do volume, I know for a rectangular prism, which is a fancy word for a box, okay, volume is equal to length times width times height. And so if I can figure out the length, width, and height of this box, then I should be able to throw it into this formula, and we're going to use that, use the max min stuff, okay, to find out what are the best dimensions, what's going to give me the best volume, the most volume, okay? Well, first things first, remember that in order to get from this flat shape to this shape, I had to fold up the flaps. And each flap, it says, is X feet. So in other words, they're equal sized flaps on every single side, right, whenever I make my cuts. And so whenever I'm talking, when I fold the box up, you can see here, then the box folded up base will be from here to here. Not 20 inches, but 20 minus the X on the left and minus the X on the right. So this becomes 20 minus 2 X's for the flaps that I folded up. In the same way, from here to here, after I fold it up, will only be from here, from each cutout, right? So from here to here. So it's no longer 16, which is the total length. It's 16, but I'm going to take a couple of X's off for each of the flaps. So this becomes 16 minus 2X. And then as far as the height of the box is concerned, well, it looks like that's just directly related to how big that flap is, right? So X, when I fold it up, becomes the height of the box. So the height of the box is X. So now I know that my volume is equal to length times width times height. There's the equation. By far, the hardest part of this problem is getting from here to the dimensions of this so I can put it in this formula. If you can do that, the rest of this problem is cake, and I'm going to show you why. See, I don't know what X is, and they don't give me a volume. Okay, they don't say we want the volume to be 100 square inches or cubic inches or anything. So we don't know what that is. They say, what's the maximum volume? What is the maximum volume? And so what I'm going to do is I'm just going to go graph it then. Okay, so on my calculator, I'm going to type in y1 is equal to, and I'm not going to do any rearranging. I'm not going to FOIL it out. I'm not going to do anything like that because that's just a chance to make mistakes. Okay, notice I typed it in exactly like it looks, right? 20 minus 2x, 16 minus 2x, X. I'm using parentheses as well because really this is a giant FOIL problem. Now, when I graph it, something curious happens. That's weird, right? I have an idea. I have my gut says that I'm not seeing the whole line. I'm only seeing a small portion of it. Like something's going on up here and something's going on to the right. And so I'm really not seeing the values I want. So I'm going to go into the table. I'm going to look at these values here. Look at this. 0, 252, 384, 420, 384. Whoa, wait a second. Look at this. It goes up, it goes up, goes up. It hits 420, and then it goes back down, right? And then I'm back down to 0, and then I'm in negative values. Well, that's interesting. Okay, so you know what I think I'm going to do is I'm going to regraph this. I'm going to change my window. The window is going to go from like maybe 0 to 7 or 0 to 8, okay, in the X direction, and then the Y coordinates, I just need to get up from 0 all the way up to at least 420, right? So I'm going to go to the window. I'm going to go from 0 to 8 for my X coordinates. X scale, remember, is our tick marks. We're going to go by ones, whatever. As far as the Y values go, I need to get up to at least 420, so maybe I'll do 450. If I leave the tick marks at 1 per tick mark, I'm going to have 450 tick marks on my screen. You can leave it. It's not going to make a difference, but I'm going to go ahead and make it like 45. That way I have 10 tick marks. Whatever. That's not a big deal. Aha, there we go. There's the volume. There's the volume. So here are my X coordinates, and here's the volume that results from the X coordinates. Okay, remember, because I graphed y equals, so the y must stand for the volume, and then this over here, these represent length, width, and height, so that's the x stuff is over there, right? So x represents this over here, and volume is represented by y. Great. I want to have the greatest volume possible, right? So that means I'm looking for the high point. I'm looking for that location. That's what I want to find. And as you might recall, how to do that is I go to second, calculate, and I want to find the maximum. And it's asking me for boundaries right now, so my left boundary, where is the high point? Well, I'm going to scroll to the left of the high point. Doesn't matter how far, that's definitely left of the high point, so I'm going to hit enter there. Then it's going to say, click somewhere to the right of the high point. I'm going to click here. Guess, I always hit enter. The high point is located at 2.945 and 420. So it's located at 2.945 and 420.11. That's the max. And what does this tell me then? Number one, it tells me that the x is 2.945. And x represented how deep I was making my cuts. How long should you make the cuts? Let's just go ahead and round it. Let's say 2.95 inches. Okay, 2 decimals. What is the maximum volume? Well, when I graphed this, remember that the y-coordinate stood for the volume. So the maximum volume is going to be 420.11 cubic inches. What will be the dimensions of the finished box? Last problem. Ready? Sorry about the bell in the background. So we're going to put in 2.95. Takes 8 rings for us to know that the bell has started. Okay, here we go. We're going to put in 2.95 for x, okay? And we're going to figure out what each of these 3 dimensions are, because we're going to have something by something by something for the dimensions. So if I take then 20 minus 2 times 2.95, the first thing, this side here, is 14.1 inches. If I take 16 minus 2 times 2.95, that means that this dimension here is 10.1 inches. And then the height is just the plane x, which means that this is 2.95 inches. And now I've done that entire problem by simply getting a graph and finding the high point on the graph. How did I know to find the high point? Because it said greatest. Okay, that's how I knew to do a maximum. So hopefully that makes sense. We'll be working on these problems in class. I know it's a little bit complicated, but the hardest part really is getting from here to here. If you can do that, you'll probably be able to solve these problems correctly.